Hello everyone, we are live with the bootcamp, another bootcamp session of AWS CDK. Today we are going to cover AppSync with DynamoDB and LambdaDB as a data source, and then we'll see how we can connect with the client side for this with GraphQL. So, Varis, can you, Sajal, do you want to add something?
I just wanted to say that it is a very wonderful feeling to have Varis with us, how he has progressed in the last 6 months. Zeeshan, you and I and all our team, that is what we are about.
Yes.
And God willing, in the next 6 months, Varis will be famous, world famous developer.
Inshallah.
Okay, let's start.
Varis, can you please start with the explaining what this DynamoDB is?
Yeah, sure. So in the previous class, we learned AppSync in quite detail, and we saw how easy it is to make GraphQL queries in CDK, AWS CDK, and we also saw how to add authorization to AppSync. So and the main thing was that we learned how to connect AppSync with Lambda functions. So today we are going to do something similar, but we're going to use DynamoDBs in Lambda function. Now, what is a DynamoDB? So a DynamoDB is an AWS service that allows you to make NoSQL databases, and it's very fast, it's very easy to use, and it's scalable. So I can actually share my screen to show the documentation.
Sure.
Okay. Wait, I've never done it before. Let me see.
It's at the bottom, the share screen.
Yeah.
And then you have to select window. So select entire screen.
Oh, okay, right. Okay. Yeah. Can you see it now?
Yes.
Okay. So DynamoDB. So let's see if we can find something useful here. Okay. Here we go. So as I said, DynamoDB is a NoSQL database, and it's fast and it's scalable. So it's scalable just like Lambda functions. So in Lambda functions, we don't have to worry about scalability. So this also scales automatically. And okay, so this is a very important point over here. They are saying that you don't have to worry about the hardware provisioning. You don't have to worry about the setup, the management. You don't have to worry about anything. You just have to initialize your DynamoDB service and start using it. Okay. So you guys can actually go through this all the other information in your own time. But I want to dive deep into some more practical theory.
Could you Varis, increase your resolution, please, a little bit?
Yeah, sure. Do you mean zoom in?
Yeah.
Okay. Okay.
Mm.
Okay. Yeah, I think. Yep. Yes. So okay. So as I said before, DynamoDB is a NoSQL database, so it's a document-based database. So by that I mean that you actually save entries in the form of key value pairs. Okay. So this document here says that DynamoDB has 3 main core components: tables, items, and attributes. Let me also open my AWS console so that I can explain you side by side. Okay, so the first component, the first main component are the tables, and you can see I have many tables in my dashboard because I made so many applications. So I made a separate table for each of my applications, and that is, I think, most of you have done this. Have done the similar way. So if I open up a table, you can see there are some items in it. I have like 4 items in this table, and items are the second core component of DynamoDB. And each item has some attributes. So you can see this table has like 7 attributes, and each item has an attribute. Like for example, the first example has the value of var in the message attribute. The second item has the value of hi in the message attribute. So this is how your DynamoDB works. So you have tables. Tables are just collection of entries or items, and then you have items, and in those items you have some attributes. Okay. Now you must be wondering how do we actually identify the items? Like DynamoDB does not make a separate column for IDs like some other databases do, like DynamoDB did. But in here, we actually use primary keys. Let me, where is that? Okay, so we actually use primary keys to identify our items. So there are two ways of creating your primary keys. The first way is just to create one primary key, and in this case, the primary key is called a partition key. Okay, so how it works is that you can actually make any one of your attribute in the table a partition key. And in this case, I have made lollypath my partition key. So this means that no two same entries can have the same lollypath, because it has become an identifier now. It works like an ID now. So that's how you can identify items in a table in DynamoDB. The other way is to make two primary keys, or you can say a composite primary key. Now, in this case, we have one partition key and we have one sort key. Now, in this case, you can have two items can have the same partition key, but if that is the case, they cannot have the same sort key, because you have to identify them, right? You have to differentiate them. So if the partition key is same, you cannot have the same sort key. Now, why do we need two keys? Like, why do we need a partition key and a sort key? The answer is that it just helps you to scan and query the table more efficiently. So I think they've also given an example over here. So if you can see this example, this is a table, and these are two entries. Artist is our partition key, song title is our sort key. So you can see in this case, both of the items have the same partition key. You have the same value in the partition key, but then the sort key is different, right? You can see the sort key is different over here. The song title is different. Now, why do we need this? So let's say that I wanted to extract all the songs from one artist in my table. So what I'm going to do is I'm going to pass the name of that artist in my partition key, and I'm going to get all the list of all the songs from that artist. Okay, but now I decided, okay, I don't want all the songs from this artist. I just want one particular song from this particular artist. So what I'm going to do is I'm going to enter the name of that particular song in the sort key, and the table would return me only one song with that particular name belonging to that particular artist. So that's how you can use partition key and sort key together. It just gives you more flexibility in querying and scanning data. So there's another way as well to scan and extract data from your table. Those are called indexes. Yeah, I think I should not go into too much detail right now. So yeah, I think we should leave it up till here. Otherwise, people would get confused. What do you say?
Oh yes, agreed.
Okay.
So
cool.
So at this moment, what students needs to understand, everyone needs to understand that it's in a complete database. So you have to learn. There are quite many things which you will need to learn in detail. So whenever we talk about the NoSQL database, we have different services available. We have what you call Atlas, MongoDB Atlas. You have a MongoDB, and in case of AWS, we have an Azure. We have other services. I guess Azure also has some service. I'm forgetting the name of that NoSQL database. And they always it's a document database, and they give a different name, so you can use it. So let's move on to the implementation. So how we can access and create something with the DynamoDB, and whatever the context we were working on in our previous class, that we have created the stack, and in stack we have created the AppSync. AppSync helps us to create a GraphQL API so that our Lambda function can be accessed with the GraphQL. And now today what we are going to add is another layer, that once your GraphQL talk to the LambdaDB, LambdaDB will talk to the DynamoDB. Sorry, Lambda function. So let me share my screen first. Okay. So in our repository, it's the step we are going to work today is step 04 AppSync Lambda DynamoDB, and it has few links which you can go and explore slowly. So once you explore them, you will learn what these are and the detail of DynamoDB. I'll just open a one which will use as a reference to pick few things to learn how we will be implementing the DynamoDB specifically. and how I'll be connecting with the Lambda functions. So that's the article. You can also explore it, and this is an important article. If you go through this complete article and implement its example, you will learn quite a lot related to the AppSync, DynamoDB, and as a CDK overall. So that's a very important article and very important to learn. So we'll follow this. So what I did is initially I had created basic CDK application, which we every week do. CDK app init -- type language TypeScript. So that's the example, first basic structure, and there is nothing else. It's just a basic example so that we can start from here. Now what we need is we need to create a stack, but for that what we need an GraphQL, we need a Lambda function. So what I'll do is I'll create a scheme folder. Let's say call it schema, or or you can call it GraphQL. I'll call it schema. Schema.gql, and just to understand, I'll just create a query, and it's exactly same as we did in the last class. And I'll create a folder for Lambda function. Okay, let's call it index.ts, and okay, and as we have learned in our previous class, we will be receiving events from the async GraphQL query. So we need to work with type so that we can provide a specific type for our event. So I'll call it AppSync event and info. We also learned in last class that this is the format we receive query name and the data. So let's skip for the argument for a moment, and we'll be assuming that we'll be receiving if event dot. Okay, I need to create event. So we'll add more functionality over here, but at this moment, initially, just to understand. So we have this schema, which just called the welcome, and we have a basic Lambda function. Now we need to go towards our stack so that we develop a stack. So as we have seen in our last class, we need to install AppSync. We need to install Lambda because we'll be working with Lambda function, and we need to install DynamoDB as well. So we need these three libraries to install. So I'll install AppSync, Lambda, and DynamoDB. And that's one thing we have also seen in our previous class to initiate the AppSync. So we are going to create AppSync service, and we need to start the GraphQL API. So we'll call the new AppSync GraphQL API, this API will go give it a name, then a schema, then authorization config. So it's an exactly same, except for the X-ray. I'll use the everything as it is. Import static as AppSync from then I need import static as lambda. Okay. So we have created API AppSync.GraphQL API. Name it any my DB API or anything. You can name it CDK. In our file name, it's in schema folder. So I created the, instead of GraphQL folder, I created the folder name schema. So just rename it. That's not a worry. And file name is schema.gq. Okay. Another thing is we need to specify authorization type. So we are using authorization for the key, and either we need to provide API key. You need to understand that if you are not on CDK 1.78 or 1.77, in the previous version, let's say if you are using CDK 1.76, so you will face the error over here. So some compatibility issues. So it's better to update your CDK to latest one, which is 1.78. Then you will not face error over here. Okay, so we have created the GraphQL AppSync GraphQL API. Now we need to set up a Lambda function, and then in that we need to connect that Lambda function. It's again the same we have done in the previous class. Okay, so this specify a runtime lambda dot fun runtime, then or 12 anything you want to use code lambda code dot from asset. You don't need to remember these constructs. They are available directly in documentation, but try to keep right in initial days of your learning so you will not forget them. That's what I do. So we have created this lambda function. Now we need to connect it. So what we'll do is lambda data source is API dot add lambda as data source. So we'll give it a name. And then we'll provide the function. Okay. So that's done. We have this data source. I have not used anything related to the DynamoDB, which is our main concern. So first we'll now we need to, what we need to do is we need to create a resolver, as these are all already been done in our previous class. So there's not a big issue for us today. So welcome. So we have our first Lambda function and the first GraphQL query, and we have this one. Okay, so now we have done with this. What we need to do is we need to create the DynamoDB table. For that, let's revert back to what we have. We can also display our GraphQL URL and API key, but at this moment I am not going over there, but we can show it easily. Okay, so now what we need to do is we need to create that table for DynamoDB. Again, we are using infrastructure as a code, so we'll need to write a construct so that it creates database in the DynamoDB. So for that, we need to install the DynamoDB, and then we need to call whatever name we given, db.table. Again, this current context, name, and then the properties. So as Varis mentioned, partition key. We'll ignore the billing mode. There are two billing mode: paper, request, and provision. So at this moment, we are not focusing on it, on the billing. So partition name, and you can also provide your name, whatever name you want to provide. Then what we need to do is we need to give, because our Lambda function will talk to the table, the DynamoDB table. So we need to give access our Lambda function to our Lambda function, grant full access, or whatever type of access you want to give it. Then your Lambda function can create or call or anything be done on your table. Otherwise, your Lambda function will not have access to the table. It will receive an error. And why we need to add environment variable, once you'll see, then you will understand, because that's a stack, and then you need to have a name of a table so that you can use that table name in your Lambda function on the server. So let's go first with that. What I'll do is, okay, so let's say we create a product table. We will be adding our product. We need to import DynamoDB. Yes. Okay, so we'll name it. That's not a table name. That's a logical ID which we give to every construct. So that's not a table name. And we'll remove it. That's a partition key and the name of your. And either you can mention table name by yourself. Let's say I'm naming it products. If you do not give a name, it will generate a name by self. That will be a longer name. So if you want to keep your table specific, you want to give a specific name, then you provide your name. Otherwise, it will be a longer name which will created by the AWS directly. Okay, then product table dot grant full access, and we need to specify the name of our Lambda function. So that's our Lambda function. Once we are done with this, okay, so the environment variable at this moment, let me just add it. What we are saying, you need to see, this is the Lambda function we have created. So we want this Lambda function to have some environment variable, and what it will be name of our table. So we are saying Lambda function dot add environment. And let's say we are giving it a table. Generally, we keep it in environmental capitals, and we'll provide the name of table. So product table dot table name. You do not have to call it by the variable because you have given the name yourself. But if you do not give this property, then that's the table name. It's important because it will be generated by the AWS and you need to have the name of a table so that you can query on the particular table. So we'll keep it as it is. So that will be our stack. So we have this stack. Now what we need to do is we need to call once we receive a call in our Lambda function, we need to do something with our DynamoDB. So at this moment, what I'm going to do is I'm going to create a mutation. And I'll say add product. Product input, as we have seen in our previous class, that if we want to create, if we want to pass an object as an input, so we need to name it as an input. Int, and we'll return a product. So you can use the same, but as it is a different input and type, so that's why. But on the Lambda function side, we can keep the same object. I'll show you, as we have done, we have already done this in our previous class as well. Okay, so that's done. We need to specify the product input, and I'm saying that we will return product. So we'll passing an object inside the mutation so that it received on the server, and then that the query will return an object, a product object. That's the basic schema we have created. Now we need to handle it on in Lambda function. So here we need to provide another if, else if, or we can go for the switch cases. So at this moment, I'm not going for the switch cases. Field name equals, okay. So now that will be our product, add product. And we need to specify that inside our stack as well. I'll do that in a moment. So once we do this, we also need a resolver for this as well, a mutation resolver. Okay, so now here, that's our Lambda function, and that Lambda function requires, so you need to understand this is key. This query will be called, add product will be called, and will receive some object. That query will received by this Lambda function. That means this Lambda function will receive some object. So we'll create argument, and we'll name it product. Okay, so ID, string, name, string, price, number. We have created a type which is a product, and we have passed it over here. So we are assuming that object we will receive from the GraphQL query, it should contain name and price. It will, we are also expecting ID, but it will be null initially because if we are not providing it, then we'll need to implement it. So this is the object we expect to receive from the client side, and then we'll use such object as an, okay. Now what we need to do is, now we need to call the DynamoDB table, or somehow we need to do something so that we can insert data into the DynamoDB. That's what we really wanted to do. So for that, we also need to install AWS SDK. npm install. Okay, that's once it's installed, what we need to do is unit name. That's not okay. So now what we need to import this AWS SDK, and there are different style. If you go from the article, you will see a different way from AWS SDK, and we can call it DynamoDB. Then we need to create a construct for this. So we call it document client or document table or anything, because it's DynamoDB dot document client. That's what it creates, the client for the document. So it means we have discussed that NoSQL, in NoSQL database, we call the table as a document. In our the language term, the documentation was showed us, they call it item. Generally, the in general context of NoSQL database, an entry is called document. So that's why it's being called as a document client. And then what we need to do is we need to call await document client dot. Now we have functions. So as we have seen the table, so we need to insert something, we need to get something, we need to delete something, we need to update something. So we have these functions over there: batch get, batch write, create, set, delete, get, put, query, scan. So put will be to add the data, get will be to get data, scan will be to, it will scan the complete document, and transaction write or transaction get, transaction write, and update as well. So at this moment we need to insert, so we'll call put. Inside put, it requires an object, so I'll show you, and then we need to call it promise. So it gives us, that's a syntax, the AWS SDK for creating a Dynamo client. And then because we want to work as an async await, so it has a function promise which returns a promise, so we'll call await, so it stays. Now this requires an object, so we call params. And the good thing is we have a documentation, everything is documentation. We are working with TypeScript. So working with the TypeScript, there is always an advantages and disadvantages. Disadvantage will be for someone who do not like to type specific everything, but sometimes the working with the typed language gives you too much benefit. Like this, I'll name it params, and it definitely will give me error, but it will show me what is expected in this object. It's showing that type is missing the following properties from type. So there is some put input type object which expect table name and item properties. You can also click on this put function and you can review that the first parameter is put item. So that's in a sum object. You can go inside that and you will see what are the properties: table name, item, expected, return value. So there are many properties which are expected in this. So if you want to explore the structure of an object, what function accepts, what property we can pass, so you either you can read the documentation or you can easily go inside the function and explore all the properties. So it's quite easy to understand. So at this moment it's saying that the table name and item property is mandatory, it's required. So we need to specify table name. Now, table name, we can, as we have provided the table name here directly, so we can copy this directly, or as we have added the table name inside lambda function, environment variable for a lambda function. So we can pass this, access this from the process. So what we can do is process.env dot copy this key. Okay. It should not be the empty or undefined, so it will give us error. I'll show you in the item. Item is an object. They are expecting an object, so we are receiving this product object inside the argument. So I'll call it argument event.argument product. Still giving me error. The error is because it expecting that this string can be null. So that's why we need to specify that if it's there is nothing inside this name property, provide an empty. So that's done. And what we'll do is we need to return an object. So we'll return event.argument.product. One more thing I forgot. As we are inserting our product into the database, so we need an ID property. As we did here, we specified, just a moment. We specified the partition key as its name is ID, so that should be an unique. So at this moment, I want to generate my unique ID, or you can use the auto-generated ID. At this moment, what I'll do is I'll generate my unique ID. So event.argument.product.id is equal to, I do not have anything, so key random. That will be because we'll receive two properties, name and price from the customer, where whatever the user will call it, or you can send ID as well. So then you have to remove this implementation. I'm assuming that the client will not send the ID. Either we generate the ID directly in the database, or either we create ourselves. So ID, and then we'll pass this ID over here, and this will be our object that will be passed to document client dot put. We'll pass this object, so it's accepting a table name, so which table you want to insert, in which table you want to insert, and what data you want to insert. So that's an item property. Once you're done with that, it will return you something just for the, so we can see we have the data. Okay, so I guess we are done at this point. We'll return. Why we'll return the products? Because our schema is expecting a return of an object. Let's try it now. npm run build. CDK deploy. Okay. Now let's move to the AWS. What we'll have, we will have something in AppSync. We will have a cloud formation. We will have a DynamoDB. We will have a Lambda function. Anything missing? We will have yes, that's it. So something will be here. So asking yes. That's our DynamoDB. At this moment, there is nothing empty. It will create a table for us. So you can see table here. You can also create cluster. So Amazon DynamoDB also gives you the option to create a cluster. So you can specify 2-3 nodes. So it will be scalability and the clustering and everything. It also managed for the cluster. You can use cluster directly. Let me reiterate one thing which should not uh, skip from your mind, that we are creating a apps. We are using AppSync to create a GraphQL API so that it can connect to the Lambda function, which we have done in previous class as well. Now what we need to do is we need to add something in database or something. So we are adding using the Lambda function, and we are operating with the database. So we are using the DynamoDB. You can use any database. Either if you don't want to go with the AWS, you can use any other database, but that will be your Lambda function. There is another option. You can directly connect your GraphQL to your DynamoDB and skip for the Lambda function. That we'll see, most probably see in future steps. Okay, so it's done. Let me refresh the DynamoDB, refresh AppSync, cloud formation, it's already there, and the Lambda function. Okay, so that's our AppSync. So we can see schema over here, we can see query over here, and the cloud formation is the DynamoDB. Okay, so we have a product as Varish showed us. So you can see that's the name of a product. Items. So at this moment it has nothing. We'll need to add something, and that's our Lambda function. And we can use its log. So CloudWatch has already been created for this. So client, we will learn client as a second step. So at this moment, this AppSync interface, as I've showed in the previous class as well, it has all the things so you can test. So let me say, call it a welcome, see if our Lambda function is working or not. Not found. So welcome is not found. That means we have not handled the welcome properly. Function is working, but welcome field name. Okay, let's try mutation. That means our mutation will also not work, but let's try. Name, price, and we are expecting the return type something. So let me call it t-shirts. So that's our mutation. We'll run this query. ID is null. So that means it's not working. There's something is missing. Let's go for the function console, functions log. Let's see if there is something. Okay, so I printed the after adding. So it's not working. That means the field and argument property has some FI. Okay, and that's a spell mistake. So it should be field name, and I use the field name. That's why it's causing the problem. When it's done, let me deploy it again. Okay. As you can see, once it's while it's being running, as you can see, we can use these mutations and we can test whatever the response from the Lambda function. We can check the response as well, and whatever happening inside the function, you can see the log. You have not created the CloudWatch, but for the Lambda function, AWS did it for itself. So you have all the logs available here. So whatever you will write, the console I wrote here. Yeah, this console will be available here somewhere, so you can see your information. And the X-ray which I have removed, it shows all the log, the stack, where what type of request it was, what data it was received, and everything. The X-ray is a very good debugging tool for the request management. Okay, so it's deployed. Let's go back to AppSync interface. Refresh it. CloudWatch creates multiple logs, so you have to check it differently again. Okay, so we have this mutation and we are expecting an ID. So let's call this mutation. Okay, so we have received ID and key something. Let's go and check in the DynamoDB. And we can call refresh. Okay, so now you can see here key, and you can see the ID, the t-shirt value, and the name of the and the price, whatever we have sent from our client. So this way you can, this is the basic, you can add, update, delete, everything you can do with this. The important thing which you need to understand is, in case of DynamoDB, you need AWS SDK, you need to use DynamoDB object, create a DynamoDB document client, and this document client has everything. Dot delete. So let's say, just I'm showing over here. Let's say delete product. So in case of delete product, we need a table name, and then we need key. Inside this we need ID, and we need to specify. We have to assume that we'll be receiving a product ID. At this moment, it is not. So in argument, I'll just you can see what it is saying. String Alam's name, key, ID. Why this? Okay, I'll check the. Okay, so basically we need to call delete. I'm calling the put delete. So here you can see, and we might need to return something. So I'm assuming it will be. So that's how you can call it, and you can have a different files and object for your work. Delete it. At this moment, it seems like this function is growing, and it will keep grow as if you will be using multiple functionality in a single file. So you can separate all this functionality, will create multiple files and call all them here. So you can do these things as per your request or a requirement. So that's how you create a delete implementation, and you do not have to do anything. Just go for the mutation. Actually, you have to write the code. You do not have to do anything. Means it's simple. Product ID, string, and string. So that is done. Add the resolver, one more. In the mutation, so we call it delete product. So it should match the schema, and whatever we are doing should match with this. Okay, so once this is done, you will have the complete implementation of DynamoDB. You can go and explore the documentation, how you can, what you can do more with the DynamoDB. There are many things which you will be using in a complete production app. So the only difference what we will have is we'll have another mutation available to us here, and we can call this mutation and will delete the key from the database. I guess this is it. It will take a bit of time. Why don't we move for the client side? What do you say, sir? I guess your mic is off.
I'm saying that you are 100% right. We want to save the time of the students.
Yes.
Let's try Varis.
Sure. Okay. So up till now, we have only used everything on the backend. We have not yet seen how to use that GraphQL or that AppSync that we have initialized on the backend on our client side. Okay. So I'm gonna be following this step 5 in our repo. So I'm not gonna be coding the backend. I'm just gonna show you what's in the backend. I'm just gonna deploy it and then start using it on the front end. Okay. So the backend is very similar to what Zeeshan has just explained. So, okay, first of all, we have initialized our AppSync, and we have added API key as an authorization. And then we have created our Lambda function. And then all the resolvers of all our mutations and queries are connected to this Lambda function. And this Lambda function is basically doing the CRUD operation, create, read, update, delete operation on DynamoDB. So like if I run this query get to do, it will fetch all the to-dos. Add to-do would add a to-do in the DynamoDB, and likewise for the other queries and mutations. So let me just quickly show you the Lambda function code. So it's using switch case over here. So it's first detecting that what kind of query or mutation is it. So from the field name, it's saying, okay, if it's an add to do, then go to this function. Go to this function. If it's a get to do, go to this function. And these functions are maintained in separate files. So let me just show you add to do function. So here we have defined our parameters, the name of the table, and the item that we need to add. And here we're just putting the item in the DynamoDB. It's very similar to what Zeeshan has just explained. So I'm just going to use a few queries or mutations from this AppSync in my client side. Okay. So I have already made the Gatsby front end, and I've already deployed this backend. Let me just show you the backend. Let's just see how does it work, the backend. Is it working fine or not? So I'm going to run few queries on mutation, and let's see if the data gets saved in the DynamoDB or not. So first of all, let's create a new to-do. Just going to give ID, a random ID, and add a title. Okay, so we're getting a response. That means the Lambda function is working fine, and Lambda and DynamoDB is also working fine. The data has been saved. We can verify that by querying. So let's just get all the data, all the to-dos that we have in the DynamoDB. Okay, so it's working fine. So let's use that on our Gatsby. So right now I'm going to show how to run AppSync with Apollo client, but there's another way as well using Amplify. We're going to see that in the next class, hopefully. So I've already initialized the Gatsby project because my computer is quite slow. It would have taken the whole class. Initialize it. And I've also installed the dependencies, and I've imported them over here. Okay. So as far as I remember, the first thing that we do in the Apollo client is that we initialize our client. We've done this many times when we were doing Netlify. So let me just create a client. And we usually used to copy paste that, so I'm going to do that as well. So this is nothing new. We have been doing this since a very long time. But there's one extra thing over here. So you can see we're actually passing a header. And we were not doing this before. And why are we doing this right now? Because if you can recall, if I go back to the back end, so if I go back to the back end, you can see that we have actually authorized our AppSync with an API key. And this means that our AppSync or our GraphQL is not public anymore. And anyone who has access to this API key, only he can actually access the GraphQL API. So if I do not pass this API key with my header, then I won't be able to access it because it's not public anymore. It's private. That's just a bit of more added security. So that's why we need to pass this API key. And where would we get this from? We can either print it on our console when we're deploying it, or we can actually.
Varish, you will have to zoom in.
Oh, okay. So if I go to my AppSync console and sorry, if I go to the settings, you can see it's giving me an API key. I just copy that. And by the way, this expires after 7 days. You can increase the limit from over here, or you can do it from the CDK as well. Just paste your API key over here, and then you would also have to copy paste your URL, the endpoint of your AppSync that you can get from here. Now this is done. Now, as we already know that we need to create a wrap root element now. Why? Because in React because we actually have to wrap everything we have to pass client to everything in the Gatsby. This was not a problem in React because we used to have one root element that was our index.js file. But in Gatsby, that's not the case. the pages are not connected. So the only way to do is to make a wrap root element. So let's do that. What we're doing over here is that we're just wrapping our entire GuideStream project with this Apollo provider, and this Apollo provider is passing on the client to our project. So this is what you have to do every time when you're working with Apollo client. Now there's another thing we need to do as well. We need to export this file in Gatsby-browser.js and Gatsby-ssr.js. Again, this is nothing new. We have done this already. Okay. Now let's see if we can run some queries or mutations. So let's see. So I'm not going to run all the queries and mutations because there are so many of them. I'm just going to run a few of them. Okay, so let's first run a query. Let's see. So first of all, I'm gonna write the data structure of my query. And where does this come from? This comes from our schema. If I go back to the backend, you can see over here the get to do's query is returning an array of to-dos, and to-dos have ID, title, and done. So every element of our array would have an ID, a title, and a done. That's why we're returning. That's why we're expecting these three to be in our output. Okay. Now we can use not actually see. Okay. Now we can actually use the hooks from Apollo client to run this query. So we can actually destructure some loading and data from the query. So just write it first. So while the query is fetching, the loading would be true. It's a Boolean value, and once it's done fetching, it would save the data in this variable, and the loading would go to false. So for now, we can just console log it and see if it works. So data. It works. It's gonna take a while. It's my computer. Anyways, so while it's loading, let me just say again that everything that we have done before, everything is the same as we have done before, but the only difference is in the Apollo client where we have to pass this extra API key. And there are like many different way to authorize your AppSync. API key is just one of them. So I think we will see the other methods later in the upcoming steps. So okay, this is done. Let's see if we have received anything. Okay, so you can see first the loading was true and the data was undefined. And when it fetched the data, the loading was false, and we have received some to-dos. Yeah, we have received one because we just made one from the console. So we know that our query is working. Now let's test a mutation as well. Just going to update on. Okay, let's run the same mutation. The add to do mutation. Again, I'm going to use the Apollo client hooks. Yep.
Varis, can you
Oh,
please
okay.
zoom a bit? And can you also show the connection between this query and the query that will be on the server, so that we see that there is exactly same available on the server for
Okay.
the response.
So you mean the code of the CDK, or do you mean in the console?
Once this query will be executed, what the server will be, which
okay.
query on the server it will map to.
Okay.
From where it
So
will be responded.
so this is our schema. So this is our query that we're running. Get to's. Okay. So this actually returns an array of to-dos. And if I go to my stack, you can see whenever we run it, it is connected to the Lambda function, and whenever we run it, it sends the request to the Lambda function. And if I go on the Lambda function, it first checks which query or which mutation has been run. So if it's gonna see, okay, wait, it's gonna see that okay, get to do has the client has requested a get to do query, so it's gonna run this function, which is in this file, and this function is doing nothing but just scanning the entire database. So you can see we're using the scan method over here, and we are passing our table name in the environment as Zeeshan has told before, and it's running all the items. So every item has an ID, title, and the done, which is a boolean, and it's returning an array of all those items here, and that's what we are receiving on our client. That's what you saw in the console log. Yep.
Okay.
And same goes for this create to do mutation. If I go back to the backend, so it's going to check over here. Okay, wait, it's going to check over here. Okay, it's add to do mutation. Now run this function and pass these parameters to this function, and these parameters are coming from our arguments. So you can, if I go back to the schema, you can see that add to do takes some arguments, which is just this, which is just like the structure of our to do ID, title, and done. Okay, so the add to do function just adds one new item, just puts one new item in our DynamoDB, and then returns it. Okay. So if I run it on my client, in this case, we get a function. We get a function that you can run whenever you want to run the mutation. So I'm just going to make a button, and on the click of the button, we're going to run this mutation. On click, handle submit, and we can make a new function over here. Yeah. So it has to be an async function because we're going to run our mutation in it. So await to variables. So you can see it takes a variable that has a structure of to do, and what is that structure? We can find that out from our schema. Let's see, what does it look like? So it's expecting an input that looks like this, that has an ID, a title, and done. And So I would have to make that over here. So constant to do equals to ID. So I think I have imported short ID, so I can just generate an ID from this library. It expects an ID, it expects a title, just for now, and it expects done value, which Boolean. So I'm going to put false over here. So in the variable to do, we need to pass this to do. So the variable comes from here, from the mutation. And yep, that's pretty much it. And we can also write that, okay, whenever this mutation runs, I want to run my query again, and I want to fetch all the data again. We can do that as well by mentioning refetch queries. And we want to run this query every time we make a mutation. Okay, so this means that whenever we run this mutation, after completing the mutation, it's going to run this query again. So yeah. So what we can do is we can display our data as well. Or let's just see what is. Let's just see. Let's just console log the data. So let's see what do we get in the output. I might have to rebuild it. And then we can also check in the console if it's getting updated in the DynamoDB or not after running this mutation. It's taking way too long. Is it stuck? I'm not sure what's happening.
What does it say?
It says
Too low.
building development bundle.
It's working. I guess it's still working.
I think in your computer,
Yeah, I
the
think
RAM
so.
is the problem.
I think
I guess
much
you
RAM-
have clicked on
how
the
much RAM do
terminal,
you
so
have?
that's why it's yes. So
should you try it? I have 16 GB. Yeah.
16 GB.
But my laptop is
basically,
quite
16
old.
GB is
Yeah.
better.
whenever your terminal has some click, then terminal is stacked. What it means, it hangs because there'll be no other input instruction.
Okay. I think I shouldn't have closed it.
I think we got the
Yep.
gist of it, and the students got the gist of it. This is for your first iteration of programming in front of a live audience. So therefore, we really enjoyed it. I think we covered step 4 and 5, 04 and 05 today.
Yep.
And in the next class, we will move forward and let's see how it goes.
Okay.
Everybody, I think we had a nice class. Waris, thank you. Zeeshan bhai, you have done a marvelous job, both of you. We'll see you next time in the next class. Thank you so much. Bye-bye.
Okay, bye-bye.
Thank you. Bye, everyone.